Good morning and welcome again to Anagon Live. This is Advent of Code Day 11. Day 11, Space Police. On the way to Jupiter, you're pulled over by the Space Police. Oh man, I really hope that this universe did not have such things as being pulled over. Attention unmarked spacecraft, you are in violation of space law. All spacecraft must have a clearly visible registration identifier. You have 24 hours to comply or be sent to space jail. Not wanting to be sent to space jail, you radio back to the elves on Earth for help. Although it takes almost 3 hours for their reply signal to reach you, they send instructions for how to power up the emergency hall painting robot and even provide a small int code program, your puzzle input, that will cause it to paint on your ship appropriately. So I'm downloading the puzzle input. Saving. Right, so we have an encode program for painting the hull, and that will cause it to paint your ship. There's just one problem: you don't have an emergency hull painting robot. You'll need to build a new emergency hull painting robot. The robot needs to be able to move around on the grid of square panels on the side of your ship. Detect the color of its current panel and paint its current panel black or white. All of the panels are currently black. The int code program will serve as the brain of the robot. The program uses input instructions to access the robot's camera. Provide 0 if the robot is over a black panel, or 1 if the robot is over a white panel. Then the program will output 2 values. First, it will output a value indicating the color to paint the panel the robot is over. 0 means to paint a black panel, and 1 means to paint a panel white. Second, it will output a value indicating the direction the robot should turn. 0 means it should turn left, and 1 means it should turn right. For those who like doing programming exercises, it does look a little bit like the Mars rover kata. After the robot turns, it should always move forward exactly 1 panel, so it's turning and then moving. The robot starts facing up. The robot will continue running for a while like this and halt when it's finished drawing. Do not restart the encode computer inside the robot during this process. So we have inputs and we have outputs. We have inputs only for the camera and outputs for the painting. Okay? The robot will continue for a while like this and halt when it's finished drawing. Okay? For example, suppose the robot is about to start running, drawing black panels as dots, white panels as hashes, and the robot pointing the direction it is facing like this. The initial state and region near the robot looks like this. Panel under the robot is not visible because a caret is shown. It's also black. So any instructions at this point should be provided 0. Yeah, because 0 is the seeing black. Suppose the robot eventually outputs 1, paint white and then turn left. After taking these actions and moving forward 1 panel, the region should now look like this with a hash. Input instructions should still be provided 0. Next, the robot might output 0 and then 0. Okay. The robot is now back where it started, but because it's now on a white panel, the instruction should be provided 1. After several more inputs, blah blah blah, it looks like this. Before you deploy the robot, you should probably have an estimate of the area it will cover. Specifically, you need to know the number of panels it paints, at least once, regardless of a color. Okay, and I get, oh yeah, so the program that we're being provided is the program that is basically driving the robot around. And what is actually our job? Is it just to manage the state? It's to manage the state of the robot. That's all we're doing, really. Basically, we're simulating the environment. So we're actually not building a robot, we're building an environment. Before you deploy the robot, you should probably have an estimate of the area, okay, the number of panels it will paint. In the example above, the robot painted 6 panels at least once. It painted its starting panel twice, but that panel is still only counted once. It also never painted the panel it ended on. So it's important to realize that it paints things only white. Well, it can paint things black, actually. Yeah. The robot might output 0, paint black, and then turn left. And does it always paint after every move, or can it just not paint at all? I think it will always paint, that's my hunch that I'm having. I'm just going to double check this. It's drawing black. Okay. The program uses input instructions to access the camera, and then it will output two values, R2. It will output a value indicating the color to paint the panel, and it will output a value indicating the direction, so we have two outputs. Okay. So we're actually running the IntCode program and just reading the outputs. That's all we're doing. We don't need to provide any inputs. Okay. Well, let's just start and see if we understand the puzzle better as we go. So we're going to read some input. I'm actually making a class called hull. So we're simulating the hull and not the robot. Maybe hull painting. And we have some example. Unit test case. Well, do we really want to make tests right now? I'm not sure, maybe not. Once we need it, we might write some tests. And I'm writing everything inside a class so that I don't have scoping problems and naming conflicts rather. What are we going to do? In Foobar, we're going to read our file. That is, now I'm not gonna mess it up. It's called file. No, it's open, damn it. Open input.txt, read lines, and we're going to trim it, I guess. Let's see what the file looks like. Oh yeah, it's an IntCode program. That means we actually can just use our IntCode that we have. Let's see, day 9. And we're going to load a program in it. Load from file. And that's day 11. Input.txt. And we're going to read it. So we are going to run the program. And we don't have to give it any input. I'm just searching again. The program uses input instructions to access the robot's camera, but it will output the value indicating the color to paint. We do have inputs. Okay, right. We do have inputs. And it's not mentioned actually how big the hull is. We don't know how big the hull is, so I guess we should just assume an infinite hull, and for that I probably will just use a dictionary with positions in it, something like that. Okay, and so for every time we get an output, we should basically read it. So we have a program that works like this, that we do an execution loop, and if it needs input at some point, it's going to return and say waiting for input. So basically we can make an infinite loop. And then here, if we are not waiting for input, then we're done. Break. And if we are waiting for input, that is the other case, that means we have to actually give it if we're waiting for input, we have to tell it the current position, the color of the current position. So I think I do need to draw a little bit to make this clear. So our grid is like this. Another green grid. And our robot starts here. And we're running the program, and it could be that the program is, let's say, running a whole bunch of time. running a whole bunch of times and then asking us for input. But I feel safe that we can say, oh, by the way, I see that my chat is not loading correctly. Hey, LaneStaff. Oh, hold on a second. Did someone change their name? Oh well, a bit confused here about some chats that are not being completely synchronized on my system. I am assuming actually that the robot will go forward 1 and then wait for input and then do its instruction and then wait for input and so on. So we're not going to have to be afraid that the robot will do a whole bunch of things and then we need to kind of track its position like after the fact. So we are waiting for input and let's read the output to see what it was gonna do. It first outputs a value indicating the color to paint the panel the robot is over. Color is the computer.output, and that's going to be the first output, so we can just pop it basically. Pop should pop the last one, but with 0 it will pop the first one. And then turn is computer.output pop also 0. And let's print it. And the turn is the turn. And actually I'm going to print here waiting for input. Alright, then we run it. We have no such directory. Is that because this one is now running inside the current directory and not inside the parent? No such file. I think I might not have saved my output, my input yet. Oh, I made day 12. Oh, right. That is not correct. Day 11. Here we should save it. Probably we can now run it. Pop from empty list. Already? Maybe that's because it's waiting for input and we first need to give it some input for the current color. Let's say it's 0 because it's black. Yeah, right. So we are just giving it 0 forever and the program is running forever. And now we need to tell it. We only need to give it inputs of the colors, that's all we need to do. Okay, so we have a hull and it is going to be a dictionary, right? Let's make it a default dict. And a default dict that would return 0 by default. And the input that we're going to give is the current based on the current position. So the position starts at 0, 0. And we're going to read the current color. Or let's call it, was it called cell or panel? The panel is, panel color is, we're reading from the hull the colors like this. You know what, I'm just gonna call it colors. Make it a bit simpler. This one is color and this one will be the new color. Okay. So there we are returning the color. This would go on forever. And once we have a new color, we can actually just save it. Position will be the new color. And then we are going to have to handle... Oh, yeah, I changed it to colors. And then we're going to handle all the turns and movements of the robot. So after we run the robot, it's going to output a direction and then it is going to drive in direction. So the current direction starts with 0 meaning up, and we're going to add the turn to that because 1 means to the right and -1 means, or 0 means to the left. So if, let's say if turn is 1, the direction is going to increase by 1, and else it's going to decrease by 1. And I'm going to change that into this, because then we can actually modulo by 4, so that we will always have at most 4 directions. And to do that with negative numbers, you need to first make sure that they're positive by adding 4 and then doing modulo 4. Okay, so now we know the directions, and then to move the robot we need to know how to move it really for every case. So we have the direction deltas, direction D, and that is just going to be a dictionary. No, it can actually be a list. So all the directions, there are 4 of them. The first direction is going up, which means 0 to the left and 1 up. The next one is right, which means 1 right and 0 up. The next one is down, which is like this, and to the left is left 1 and 0 up or down. So dx dy is now the directions array, and we take from that the right direction, and then we're going to change our position to be basically, we're going to add dx to the first part of the position, and to the second part we're going to add dy. Now we have our position, and I think that's it. Let's see. We cannot do item assignment like this because, okay, we need to make that a new tuple, a new value actually. So let's do it like this. Overwriting the entire value there. And how do we know when we're done? When the computer is not doing anything and it's not waiting for input. This is taking a long time. Probably we should disable the debug mode on the computer. Debug is false. And we run it again. It says pop from empty list. And why is that? So we have no more output. So it can be that actually we are finished, perhaps. Perhaps we are already finished. Maybe we can check this first. So we run the program and then we just break right away. And then what do we need to do? We need to keep track of how many faces we painted, and we need to count it uniquely, something like that. The number of panels it paints at least once. But if it paints it black, it also counts as painting, right? But if it paints it twice, then we shouldn't count it. Regardless of its color. So let's say that we are painting a panel first white and then black and then white again. Okay, so we basically need to keep track of all the panels that were changed color. And basically that means the positions that we visited. And that's very easy because that is actually just stored in our colors list. Now I don't like the colors list anymore. I would like to call it panel colors. And the length of the panel colors, that is the one. The length of the values. And then, you know what, actually we're going to print it. I see, Zarankiewicz, that you've solved puzzle 1, part 1 and part 2 already. Congratulations. Always very fast. Hey Eric, make sure you click the first link in the puzzle today. Oh, I should click it. Okay, let me see. Space Jill. Oh, that's a video. I hope my computer can handle it. Oh, the one pulled over. You know what? I almost have my my code done, so I'm going to see if my output is correct. Pop from empty list. Oh. If not computer waiting for input break. Break is not the right one. I should do a break. I also should do a break if my computer has no output, I guess. And so now we get 0. So I guess that is not correct. Okay, so I don't know how to stop it. Okay, so let's see. Pulled over by Space Police. Oh, I have not logged in yet on YouTube with my Safari right here. Sorry, Eric. I will definitely look at it, but first I'm going to try to get this one done. Thanks again for a nice puzzle. I like this one. I always like robots that move around. It's a lot of fun. But we don't have a correct program yet. So I'm going to actually print the grid. And now that's going to be a little bit more difficult, because our grid is actually not fixed, it's growing in size. So let's keep a min x and a min y. No, let's go at x range, which is none, none, and a y range, none, none. And then as we move, we are going to update that range so that we can render it properly. When I started reading this, I thought you could make us program Langton's End. Was this in your mind when you made this, Eric? I don't know what that is about. So if the position, let's say we have xy from the position, if x is less than, if x range 0 is none, that means that we can update the x range. X range 0, which is the lowest bound of x that we have, should be the minimum of those two. And x. And when x range is none, then basically that means that the upper bound is also not filled in. I'm not sure why PyCharm is highlighting this. Tuples don't support item assignment. Okay, then we'll replace it with a list. Okay, cool. And then the y range. Yes, the int code today is the brain for a version of Langton's End. Oh, I guess that's something we should look into after the puzzle. So we now have the maximum values. You know what I actually can do without printing the entire grid? I can just debug. We can just look at the panel colors. So we start with nothing, and then we do one loop. And these breakpoints are no longer relevant. And this... Why do I get a break here? Alright. Oh no. Okay, I think it's because I'm doing a minimum with a none, but I'm not entirely sure. So I'm just going to remove that code. We don't need it right now anyway. And this is actually not an error, it's just I'm watching some variables that no longer exist. Maybe Conway's Game of Life next. Yeah. Last year I made a cellular automaton, so I guess I'm up for that. So after running the first cycle, we have a set of panels that looks like this. We've painted a 0, we've painted a 1 there. and then we're going to the next iteration, and it looks like we have not actually moved our current position. Let's move this one up a bit if we can. We can, and our current position is here. So we have moved actually, and the robot will start pointing upright. That is correct, and we need to move also. Yeah, it's also what we did. Okay, and after moving, then we should have. Shouldn't we get a new color in the panel? Yeah, we do have it now. And then it moved there, and the direction I will keep it here. So direction 0 means hold on. Yeah, direction 0 happens after we turn first right and then left, for example. So turn here is 1, and so at the last turn we turned right, and then we are facing north again. We run it again, and then the last turn was 0. You know what, actually I think I'm going to break. Let's see, I want to break at the end, although that's actually what I'm doing. I'm breaking at the end of every loop, pretty much. So now we have our positions like, wow, this is hard to keep track of. Let's use a whiteboard. So we start here, and our first turn was going up, I think. Oh yeah, I need to do it with debug on. Hi everyone on the chat and who just joined in. I'm solving part 1 of day 11, and Zarankiewicz and Stovoy have already finished. If you are still working on it, but you would like to get a little reward, a visual reward when you finish, then do sign up on the leaderboard. The leaderboard has a code which I am going to paste here on the chat. It's this one, and then you'll be shown here right above. I do hope that my alerts are working though, so I'm going to do a test to make sure. Yeah, today it didn't work, I think, Zarankiewicz. I'm sorry. There was a problem, and thanks for following, Userman. I'm going to refresh this page and see. Okay, so this is actually the demo of a gold star, and a silver star will also show up. So hopefully for the next person you will get the real reward. So we were looking at our code. We have our robot and we're running it, and we're checking in the panel colors to see if we are actually tracing the robot on the right positions. So after the first iteration we are at 0, 0. Does that sound correct? I'm not sure if that is correct, because we already should start at 0, 0, and after right, okay, yeah, I see what's going on here actually. So we are only writing the changed colors. So basically we start here at 0, 0, and we move. We don't really move forward. We give the robot an input of a 0, which means black, and we are going to run the program, right? Maybe we should first give it an input and then run the program. That makes a lot more sense actually, because the first thing it's going to do is to ask for input, and if we don't provide it input, it's going to wait, and then we're gonna have to run it again for another iteration. So I guess this makes a bit more sense. So then before we run, we have the panel colors on position 0, 0 being black, and then we can run the program for one iteration, and then what happens? This. So the panel colors in the background, I think you probably cannot read it, so I'll just read it for you. Panel colors indicates that oh, I saw a star on the screen, and that must have been Hans Anonymous. Yes, congratulations. Good job on finishing quite quickly. So in panel colors we have position -1, 0. That means 1 to the left. That's here. And our last direction was direction 3. And that could be correct, I guess, but there's something a bit strange. If we're starting up, we should also move up, right? And now I really want to check, do we move before running the program, or do we only move after the first iteration of the program? Because it doesn't make a lot of sense if you start pointing up and then the first thing that happens after is you're on the left. Because if that was the case, then starting up doesn't really have any meaning. The encode, okay. You're welcome. Good luck on finishing today's code. I actually really enjoyed today's. Well, that's nice to hear. I think this will be a fun one for a lot of people. It's kind of easy to understand what you're doing. It's visual. And I think people might have practiced something like this before, like a Mars rover or some other thing that moves on a grid. After the robot turns, it should always move forward. The robot starts by moving up. I think it doesn't really make sense to move the robot before running the program. So we run the program and the program will tell us where we should turn. But I'm really not clear about it, but we do have examples though. So the robot is about to start running. That is an important detail. Drawing black panels as dots, okay. The initial state is like this. The first one is also black, so any input instructions at this point should be provided 0. Suppose it eventually outputs 1 and then 0, turn left. So it actually did go left right away. So that's actually what's happening in my example also. So that's not wrong per se. Okay, so let's run it then again for another iteration. Like this. Now we see that our last direction was 0, which means basically up. How do I do this again? Because we have turn and we have directions. And turn is just left or right, and the direction is the absolute direction. Okay, so the last absolute direction was 0, and that means going up. And that means that we should end up 1 above, and that is what you see right here. So that also looks correct. Then I'm actually going to just run program again and see what we get in the end. If we actually don't crash like we were doing. We do pop again from an empty list, and that can be that there is no output, but we still halted, and it says that we are not waiting for input, so we should be halting. But maybe I'm not resetting waiting for input after reading input or something. Oh, so if we already have input, hold on, where do I actually reset this input? When we provide explicit input, then we are setting it to false. So here, if we are providing input, we're setting it to false. And then what else happens? If we are reading from inputs and we have no more inputs, then we're saying that we're waiting, and otherwise we're just popping. And actually, after we're popping, I think we should just keep track and say that we're no longer waiting for input, right? I think that makes sense. So let's do it like that and run it again. Yeah, now we're finished, and this is actually our number. So let's see if that was the number of panels that we painted. And it's correct. Nice. Okay. That wasn't too hard. I did spend 35 minutes on it, so it's not like the fastest in the world. Thanks for the cheers, Aneurysm9. And hands. Like this. Woohoo! Day 11. Oops, day 11. Part 1 solved. And now the next one will be what? How can you implement a Turing complete computer with just black and white painting? No. Part 2. You're not sure what it's trying to paint, but it's definitely not a registration identifier. The space police are getting impatient. Okay, so what does it paint instead? Oh, you know, checking your external ship cameras again, you notice a white panel marked Emergency Hall, Painting Robot Starting Panel. The rest of the panels are still black. Ah, but it... Oh, hold on a second. Looks like my headphones are not charged anymore. But it looks like the robot was expecting to start on a white panel, not a black one. Okay. Based on the space law attached to one of your windows, a valid registration identifier is always 8 capital letters. After starting the robot on a single white panel instead, what registration identifier does it paint on your hull? So how do we find this white panel? How do we... we can actually run our program on every position and then see what the robot tells us? That's kind of funny. No, hold on. Wait. The first panel should be white. Should we then just tell the robot that it's white? Hey, Divas Ray, good luck on getting part 1 done. Yeah, okay. Thanks for that hint. I think I just figured it out on time. So the first color, it's just a bit of coding mess basically. So iters, the number of iterations we did is 0, and then iters plus 1, and then if... Oh, what am I doing? Come on, this is completely not necessary. We can just overwrite 0, 0. That's 1. Okay, and then we run it, and then we need to see what is written. Yeah. Okay. So for part 2, I'm going to print everything, and that means now we actually do need to keep track of those minimums. But you know what? I'm just going to grab the minimum after finishing the whole first part. So the min... Let's see what we can do there. Let's first get all of the x's out of the positions. So x for xy in panel colors dot keys. So these are all the x's, and then the min x, the x range is basically the min of it and the max of it, and the y range is something similar. You know what I could also do is just paint a very freaking huge thing. That's what I'm going to do. So I'm actually just going to guess for y in range minus 100 to 100. I will start with 100 and then see if I need to make it bigger. Then we're just going to print a character. We're going to print the panel colors at that position. We're going to get 0 anyway if it doesn't exist, right? And we're going to print a hash if panel colors is 1 and else. I am going to use space for that, just because it makes it a little bit more easier to see with no line ending. And then at the end of every row, we are going to print nothing, which will make sure that we have a line ending. Okay. Let's see. I don't see output. And why is that? Maybe it's to the right. Oh, Okay, we see nothing. Nice music, by the way. I like this sort of music sometimes. So if it's one... Let's do a debug. A little debug. Our panel colors. Okay, and we are not gonna break. Our panel colors really have a lot of data, and it looks so far that it's all positive, and it's not that many items basically. Basically all of them are between 0 and 50 or so. So I'm just going to start with 0 to 100 and X range also 0 to 100. And then the values are really correct and we are printing. So that really should work. Oh yeah, there we go. So it's EGZCRKGK. Yeah, okay, that was it. I don't know why we didn't see anything before. I guess it was just somewhere out there, but I didn't pan it right. Indeed, I think it should be somewhere on the right half. And then, oh yeah, you see? Hold on, there it is. So that's kind of funny. I'm not sure how I would avoid this the next time, but yeah, that worked. And here's a little trick that I did, and I learned it from other great people solving puzzles last year, is that sometimes it's really good to just look at your data. So just run it and see basically, you know, there's always some kind of pattern. So here I just see, okay, so they're basically all positive. You can conclude this very quickly, and you can see where the values kind of go. Rather than just writing solvers for everything. You don't have to solve everything by code. You know, there's no requirement that your code could run on any arbitrary input. The requirement is that it can run on your input and on your case. So that's something you can do. Nubali, congratulations on solving also. And for the first time in the last 5 days, I think I am rather quick, I would say. Like, at least I was number 4, and I've been dropping very much in the ranking in the last few days because the puzzles are getting more complicated, and I think that the more complicated the puzzles are, I probably relatively become slower. I'm not really sure why that is. Maybe overcomplicating things, or maybe drawing out too many things. Although, for me, drawing out is really the best way to get the puzzle right. So, I am going to commit. Oh, does anyone know who is using PyCharm or another form of IntelliJ? Why I always get a commit message filled in here that is not the last one? It doesn't make any sense to me. But I've changed already a lot of commit messages before, but it's always keeping the first one of the day or something. It's just very random. And I don't want to commit anything else because that's some refactorings I was doing. Not so important right now. Day 10. Oh yeah, that was just an example. Okay, so this one is solved. Valerie, I think I just missed your completion of that puzzle. Congratulations. Good job. Good luck on part 2 also. Valerie, I think you're new on this chat. You're not online right now, actually. It does look like that. Do let me know if you're watching this, what your Twitch username is so that I can link you correctly. I tried to look you up yesterday, but I couldn't find you. So help me out there, please. Alright, Zarankiewicz, I am relying on you for the first review. I am sure you have some code online. Can we have a look? So, how is everyone doing so far? It's 11 days already into the puzzle, and it's into the Advent, and it's very tough, I would say, to do so many puzzles every day, but I do have time for it. I wake up very early. I wake up at 5 o'clock or so, so I do have time every day, but still, you know, it takes quite a lot of discipline to keep up. I have participated last year, that was my first time, but I really was not as dedicated as I was now. I was really cherry picking the problems that I liked, the ones I was interested in, and I specifically did not join on the puzzles the one puzzle that had int codes or op codes in it, because I thought it was very complicated. It just intimidated me a little bit. And this year, of course, I've been doing all of them, and it wasn't as bad as I thought. I think I copied the wrong chat, because I'm seeing now, the wrong link, because I saw an int code computer. Yeah. Maybe my code is a little bit weird, but I had this callback system for handling outputs of VMs. That's why I do it that way, not that pretty. Ah, okay. You had a callback system, I see. Yeah, I remember. Oh, I know why you're giving the int code computer, because that's the one you're using. Right. So you include the whole code in the solution. Ah, that makes sense. Then you can just run it. Thanks for that, by the way. That means that I can actually just copy paste it and run it here somewhere. So let's make a new file for you. By the way, I looked up Zarankiewicz. Apparently it's a Polish mathematician. How come you chose this name for your Twitch account? Just so you can run it if you want. Yeah, that's not you. I figured there was a kind of historical photo on your GitHub, and I imagined that you were probably not a 70, 80-year-old man with nice retro glasses. That's what you did as well, so also let me share your my solutions and not spoil. Sure. Yeah, Aneurysm, feel free to also post your links. Maybe wait until I'm ready to show it on the screen. Yeah. It is a cheeky name, but I'm not familiar with the guy. So to me it didn't ring a bell, but for mathematicians perhaps it does. So this is your VM, this is your int code computer, and it's just amazing how short it is. Again, I really feel like refactoring my code. It's 100 lines exactly. 100 lines, excluding the class name. And let's see how it works. Shall we actually run it? Let's run it. And I need to change the input file name. That would be in day 11 for me. Oh yeah, there we go, the same output, and it's really fast. I guess no printing statements make it faster, as I have pointed out a few times. And you do get a min and a max, so that's the one I was too lazy to do, but you actually did that. And here we can see how much work that actually is, just a bit of copying. It's not too bad. Okay, so part 1 is you have a VM, you have a starting position and a starting direction, and you have a grid. Basically you did it exactly the same way as I did, and you have a which. And which, what is which for? Let's see. So you have, I think you're, I see what you're doing. You're switching different handlers for the outputs. So either you're reading the first one or you're reading the second one, and here you're just kind of switching between them. Yeah. So which is a switch. And so, and this is the callback, right? Okay, and you're adding the callback there, right? I guess what you could also do, I'm not sure if there's a nice alternative for that, but I was thinking you could pass like the computer, or you could access the computer as you were doing here, kind of with globals. You could access it from the callback and see something. it kind of defeats the purpose of having callbacks, of course, because your dependency is completely hardwired, rather than callbacks which are nice and independent or not uncoupled. So if we're dealing with the color, we're writing it to the grid. If it's a direction, then we're what is this? If it's 0, wait a second. We have 0 to go left and 1 to go right. Okay, to go left, what you're doing is you're flipping the direction. Oh, right. You're switching coordinates. So actually what was dy becomes dx, and what was dx is going to be negated and becoming dy. And if you're going to the right, it's like this. Wow. Wow. You know what? At my work we've done, yeah, it is really clever, but I do realize I have seen it before. It's basically just some coordinate flips, and I think it is equivalent to matrix multiplication with some values in it. I don't know what values. But so what I was gonna say, at work we've done a lot of code katas where we solve the Mars rover kata. It's pretty similar to this one. Basically, you implement a little robot on a grid that's pointing up, and you can tell it to move forward and to turn left or right. And those are the only instructions, and then your purpose is to kind of map it out on a grid and to keep track of its position and orientation. And we have a lot of discussions on how to implement the directions and like how to implement the dx and the dy. But in even 8 times that we were doing this, no one came up with this solution. And I guess how that happens is that you don't just come up with it. Maybe you do, but you need. Well, for me, I need to learn this from someone else who knows this approach. And if there's no one in our group who knows this approach, then we're never gonna figure it out, because if you have already like 3 or 4 ways to do it, you're not gonna come up with this. But I think it's really cool. I think it's very cool. So basically you can implement this direction changing with just like an if-else statement and 1 extra line. So it's like 5 lines of code, or 4 lines. Very, very elegant. Okay, and then in the end you're counting, I suppose, the length of your grid. So I did length of grid values or keys, but that's not necessary. I can just do the length. In general, on dictionaries, that's some question I had. If you do any operation on a dictionary in Python, does it work on the keys or on the values? So let's say we do a count or a for loop, and we say do a for loop over these over this dictionary. Does it do the values or the keys? Please let me know. So we are going to look at Aneurysm 9 at their code. But it says, I also thought it could be done with rotation matrix, but ended up doing just a bunch of if-else statement. Yeah, you can do it, of course, with some kind of matrix, but then you do have to have a language that supports matrix calculations. And oh, you actually posted a little snippet of what you were doing. Yeah, so up means, I see. Okay, so you basically make a map from every angle to another angle, no? Let's see how this works. Which language is that actually? It's Go, okay. So we have up, and that's the direction, yeah. And we have rotations, and that maps rotations to another direction. And you have left, right, up, down implemented. Those are the ones right here. So if we have a rotation, I'm not sure I understand the syntax here. I think it's a struct. I'm not sure. Rotation should be... What kind of structure is that? Oh, it's right here actually. A rotation is a struct with 2 parameters, a from and a direction. Oh. So it is from up 0, you go left. So I'm not sure why you need... Ah, I see. Okay, so basically what I would do in Python, most likely, for those who are more familiar with Python, I would probably make a two-dimensional grid, like rotations like this, and then I would say like current direction or something and target direction, and then in it, and then rotation, which could be like 1, for example, that means turning right, and that would have some kind of direction. For example, that one would be then down. But in Go, apparently one way to do it is to make pairs. And I was curious how you or why you decided to do it with tuples. Well, I'll just call it tuples, but they are basically structs, which apparently can be how do you say, they are comparable in such a way that if you write a rotation up twice like this, that they are going to be recognized as the same index in that map. Go allows using any comparable type as a map key. Okay, I think we have the same benefit in Python. So that means you could do it like those struct, with the struct approach in Python too. Okay. Shall I go also over the rest of your code? You did highlight this part, but there might be something else to see there also. So here's your int code computer with the opcodes and VM. Yeah. And so one thing I know about Go that other people might not know is that Go doesn't actually have classes and objects. You have functions, and you can restrict functions to work with certain structs. Am I right about that? So you can kind of do object-oriented style programming, but you don't have objects and classes. In Python, the keys need to be hashable. Okay, that makes sense. And you can add methods to any type in Go, pretty much. Oh, so you can also add methods to integers. Oh, that's cool. And then what it means in Go, that if you do like this dot foobar, that's basically an alias for this? No? I'm not sure about that. But basically the way the methods work is not that you actually add a method to an integer. It's just a function that takes a certain object as an argument, and that means that you can use the dot to kind of reverse the order. But I don't know in Go if you can use both, let's say, formats, or are they really equivalent, or is it more a conceptual way to think about them? So part A, let's have a look at part A. So we're reading the input and passing it into the VM. If you look at around line 210, you'll see a method added to the VM. Let's see. We can actually learn a little bit of other languages. That's cool. So here you have a function that takes a value called m, and it's of type a pointer to a VM. I suppose it's a pointer. And the function is called run and doesn't take any other arguments. I suppose that's how it works. So basically this is your function definition as you would have it in most languages, but then here it's basically the types it can run on, right? And you return an integer. Reminds me a little bit of receivers in Kotlin. So in Kotlin you can, well, I actually don't know the syntax by heart. Go also calls it a receiver, and it's what the method is attached to. Yeah, that's such a cool concept, a receiver. So in Kotlin, let's say you have a class called foobar, and it looks like this. Then if you want to add a method to that, you can basically just say fun, and then hold on a second. I think a receiver in Kotlin is a little bit different. So I can say hello, like this, and that would actually run on foobar, and that means that we have access to this. But a receiver in Kotlin means something else. So a receiver is like this. Let's say we want to run a bunch of code on a foobar instance. So let's say we have a foobar instance like this, and normally we wanted to do like a is 1 and foobar.b is 2 and so on. You're going to have to repeat foobar a lot. So instead what you want to do is to call an initialize function that takes a receiver like this, and then you can just do a is 1 and b is 2, because so basically this is what you want to do, but in Kotlin you don't have to write this, so you can just leave it out, and that makes it very compact and simple to write. But to implement initialize, you need to actually define that you're taking an argument which is a receiver function, so a function that's going to work on another object. So the initialize function would look something like this. Initialize, no, actually that doesn't exist inside the foobar class. It just inside exists. I think I'm confusing myself here a little bit. So Hans is doing everything in Kotlin this month. And have you already used receiver functions in Kotlin, or is that something that you haven't needed to use or not been able to use yet? I'm going to leave this explanation here on the shelf because I think I'm probably not getting it right. Maybe someone else can clarify that. So we were looking at Aneurysm's implementation in Go. Oh no, you changed your mind. Ah, so you didn't actually write it in Kotlin this year. Okay. Well, I was writing Kotlin last year, and I was loving Kotlin a lot. I loved learning the language and using it. It's very clean and elegant, but as I was solving the puzzles, I noticed that I'm very much invited to create abstractions. So, oh, I can use a data class for this. Oh, I can use a class. I can make enums and all that stuff. And it's just so clean and elegant to do that in Kotlin that I just started really quickly focusing too much on building a big domain, like a domain model, and that really got me stuck. And with Python, I'm just more invited to work with simpler constructs, and because it's simpler and more low level, I don't run into wrong abstractions that quickly. And in Python, I really make only abstractions when I need to. And it's not really the fault of Python or Kotlin, or like, it's not really because of the language itself, but it's kind of the mindset that you adopt when you use the language. So if you can use Kotlin and like really keep your classes out of your code until you really need them, then I think you can be more effective. But you still have the problem with the development debug cycle. So you're running your code, have to wait for the compiler, and then you see your output, and usually it's about 10 seconds for me for a single run, and in Python it's just like instant. So I do like the quick feedback of Python in these kinds of exercises. So part 1 of today's puzzle, made by Aneurysm 9. We're making a VM, passing the input into it, and we have a location that is a point struct with no parameters, so I'm supposing that the default positions x and y are going to be 0, and we have a grid struct. Well, I guess it's a struct. It's actually a map, okay, and it has points in it. Okay, so that's the same as what we were doing also. And you're facing up, and you have the min and the max, and you're overriding them here. See the bounds of your map, and then you have here a mutex. I know that mutexes are used for threads, otherwise I don't know very much what they do, but I guess you're running things in parallel maybe. And you're locking, and you're doing some loop unless you're done, and your virtual machine, which is am, is going to be written to it the color of the current location, and then you're reading the color from the machine and the direction, you're writing the color, unlocking, Can you clarify why you need to run it like this? Are you running anything in parallel? Spawn a coroutine to handle the I/O and run the VM on the main thread until it ends. And you're getting the facing direction by looking it up, by looking up the current direction with the turn. And yeah. Okay, yeah, sometimes people use different terms for things and that got me confused for a second. So in your case, direction is what I call turn, and what you call rotation, I call direction, pretty much. Location X is changed and Y is also changed, and that's it. And then in the end, you're drawing the whole map by iterating from the rows till the and then the cells vertically and then horizontally. And then you're writing, and in the end you do need to return something. You're actually returning the string, but where do you keep the outputs? Do you store them somewhere? Do you store the number of painted tiles? I don't see any increments here. You have a harness that can run each day. Hold on. So you're saying that maps are not very safe for concurrent access, and very occasionally you run into a concurrent access error. The lock prevents that. I have a harness that runs each day. Okay, that's part 2. But the question for me is like, why do you run things asynchronously in general? Because what if you would just have run this function inside your... Oh, I am looking at part B. Oh, right. So part A, yeah, I just kind of jumped to the wrong location. So for part A, you did have a count. You're doing something similar, and the thing that you did extra was keeping the bounds, and the rest is pretty much the same. And you're using the locking, which you didn't do in the previous part. So yeah, why you lock, and why not just run this code as you did? Oh no, you didn't do that here. But why not just run this in the main loop? If you want to have your code reviewed after this, do paste your code on Gist or on Pastebin or somewhere else, and we'll have a look. It can be any language. It can be Python, Haskell, Java, Kotlin, PHP, Crystal. I see Crystal is not. Crespol is not online today. He was online in most of the other days. The channels are blocking. You do it concurrently because mrun goes until halt, and I use channels for I/O. Oh, okay. I guess that's what you meant when you were talking about I/O before. Yeah, I didn't catch that. Sorry. So when you're waiting for input, basically you're blocking the channel, and it would continue when the input is received again. And to do that, you do need to run things concurrently. Yeah. And read and write just wrap around the channels. Let's look at what mread and write does. So read looks like here's the definition, and you return the output, and that is this a kind of yield or something, or a pop? Can I consider it a read from the output array? And write is doing... Yeah, it means read from channel. Okay. Right. And this is passing something into a channel. Okay. I opened a few windows this morning, and now it's getting very fresh. It's December, of course, and it's Europe, and it's not that warm, so I'm going to close the windows. One moment, please. Okay, that's better. I don't have a big sweater on right now, and I don't want to have cold fingers. Not a big fan of cold fingers. So the arrow points to a channel. Yeah. Okay. Any other code that we have available that we can look at? In the meantime, let's run some code for fun. Oh yeah, the -100 was really not a good idea. I'll just change it to what I know the output to be. It's like 50 by 50 or something. like this. Actually, it's 50 by 10 by 7, 6. Yeah, that works. That looks right. And I was wondering, so among all of the puzzles we've done so far, what has been your favorite? What's the one that you keep talking about? Valerie, congratulations on your gold star. Good job on finishing it and holding on and pushing through till the very end. I'm tuning out. Have a good day. See you again.